Hi, it's Richard Joe back again, CXL Certified Optimizer. So this is part 2 of the Frequentist versus Bayesian statistical models which you can apply in CRO and experimentation. And I spent most of the last video talking a lot about the Frequentist model, what exactly it is, the pros and cons, and those kinds of things. And I was talking about Bayesian statistics until I got cut off because it's only 3 minutes. So the thing with Bayesian statistics is, like I said, it's easier to communicate test results with your stakeholders. So say you're working agency side or client side, whoever it is, you're always going to be talking to a stakeholder, and not all of them are going to be clued up on statistics. So with the Bayesian sort of model, it's basically the way it works is you get a test result. Say your test is a winner, you will declare the test a winner at, say, 80% probability. So what that means is there is an 80% chance that the variant, if it's a winner, is beating the control. And that's not the kind of statistics that you get in the Frequentist model. So it's a lot easier for a stakeholder to understand. It's a lot more intuitive for them to understand without getting into the nitty-gritty of all the stats and p-values and z-scores and null hypothesis and all those kinds of things that you get in the Frequentist model. It's just easy to understand. Is the variant better than the control, yes or no? And what's the probability of that? The thing with the Bayesian model is also that it does use what's called prior knowledge, and that is also something that also, depending on your Bayesian model, so say you're using VWO, that stats engine would also, as it gets new data over time, so let's say you run the test over 2 or 4 weeks, it gets more data and it actually adapts the probabilities. And there's pros and cons of that. The pro of that is that you could say it's maybe in some ways more accurate because you're taking into account prior data, knowing, say, the probability of doing a previous test similar to yours was this, and then you get incoming data as the test goes on, so it actually adapts. The disadvantage is that it does take a lot of computational power and will require a lot of, like a really good stats engine. So there you go. Thank you.